Hi everyone, it's great to meet you all once again. Myself Valarmathi, Assistant Professor, Department of Information Technology at SA Engineering College. Today I am going to discuss about the topic as IO scheduling in operating system. Let's see. The agenda of this today topic is basic idea, that is the basic idea behind this topic, and the moving head disk mechanism, IO handling algorithms, first come first serve, shortest seek time first, scan algorithm, C-scan algorithm, look algorithm, and then conclusion. The basic idea, or you can say it as an introduction. What is the operating system? How the IO scheduling is done? The IO scheduling is nothing but how the operating system will schedule the IO request. There will be lots of IO requests will become. The what way the IO request will be serviced. That is the mechanism in which the operating system will service the IO request, or you can say is the order in which service the IO request is scheduling. In IO scheduling, the major portion is disk scheduling, because the majority of the disk is used to transfer the data from the memory to disk. So that before you going to see about the IO scheduling, we have to know about the disk mechanism. This mechanism is, in this mechanism we have multiple platers. The multiple platers are mounted on a spindle. The spindle will rotate itself as well as the platers also rotate. While rotating the spindle, the read-write header will read the informations, also write the informations. The read-write header will not touch the platers, because if you touch the platers, the disk will be corrupted. Without touching, they read the informations or write the informations through magnetic fields. In this spindle, the platers are mounted. The platers, every platers has the upper surface and the lower surface. In this surface, we have a tracks. Every tracks is covered with this cylinder, which is represented as dotted lines. This tracks is divided into some multiple sectors. In this sectors, which holds the control informations about where the data is stored, it is divided into three parts. We can represent it as, in this sector we have the header, data, and the tail. The header contains the information about the starting address of the data, and the tail contains address about the ending address of the data, which is represented usually the physical address is represented as cylinder number, and then header surface, and the next the usually physical address is represented using the cylinder number, and then surface number, and then sector number. The sector cylinder indicates which cylinder the data is present, and the surface indicates under the cylinder which surface the data is present. Sector, in this every surface we have a n number of tracks. Under this track, which tracks the sector will be present. Next, how this will be handled using the scheduling algorithms. In this, the address, that is depends on the physical address, the data position, the header position will move from one place to another places. If you have it takes a longer distance to travel, at that time the disk access time is more. If the disk access time is more, the CPU performance will be reduced. In order to avoid this, the operating system designer will adapt the better scheduling algorithms, so that whenever the order request is received, they will start concern about the order servicing the request. As soon as the order is received, servicing the request is a better way to choose the scheduling algorithms. In this, the IO request is handling algorithms are first come first serve, shortest term first, scan algorithm, C-scan, and the look algorithms. In this, first come first serve, before we see about the algorithms, we have to know about the IO queues. What is the IO queues? For example, in a particular disk, some pending tasks are there. The pending tasks are arrayed in a form of queue. Every device will maintain a queue. Some devices will maintain a separate queue for the IO request. It contains all the IO requests. That is, it may be a request from the printer, or it may be from the disk, and so on. Some devices will maintain a separate queue for every IO devices. That is, if large number of IO devices are connected, at the time it uses these separate devices. In first come first serve, we will see the service the request in the order what they arrive. It doesn't think about the matter how long the distance is. It will service the request in which order they are arrived. That is the first come first serve. The drawbacks of this first come first serve is without considering distance it travels, and also in between traveling if we have some pending requests also it will not serve. It will serve only the order in which they arrive. That is the disadvantage of first come first serve, but it is easy to implement. For example, consider in a queue I am having the cylinder number 98, 183, 37, 122, 14, 124, 65, 67. The header is start at 53. Currently my header is present at 53. It moves on to 69. But in between these 53 and 69, we have pending requests of 65 and the 67, but it will not service the request. It will directly move to this 98, and next it move to the 183. After that, it will come back to the 37, and then 122. Next, it move to 14, and then 124. Next, 65 and 67. For this, it will take more time, or else we can say it as seek time is more. The seek time is calculated by once the directions changes, we have to subtract with the last values. For example, in this example I am taking 183 minus 153 and then plus 37, that is subtract with the 183, and then 122 minus 37, 122 minus 14, 124 minus 14, and then 124 minus 65, 67 minus 65. At last we will get a 467. Next is the shortest seek time first. The shortest seek time first is similar to that, but here it will service only the nearest cylinder request. Whatever cylinder which is present nearest to the header, it will be served first. That is, it will minimize the seek times. Compared to that, it will minimize the seek time. The disadvantage of this shortest seek time is starvation. Starvation is when it's servicing the nearest request. At the time, the request which is present a long distance will keep on waiting or blocking. Therefore, the starvation will occur. And also the time may also occur in this. Suppose if I consider if I have a request, currently my header is present at the 100 position, I am getting a request as 99 and 101. Which request it will service first? So we may choose in two ways. One is we can choose the first come first serve process or also algorithm, or we can say it as another way is choose the algorithms to traverse in the same directions without changing the directions. For example, currently my header is present in 101 and traveling the directions of 50 to 100. I have to travel in the direction of 101 instead of traveling from 100 to 99. If I change the direction, it will take more time compared to traveling from 100 to 101. An example I am taken for the SSTF, that is queues 98, 183, 37, 122, 14, 124, 65, 67. Again the header is placed at A53. Now the shortest distance is compared to 65 and 57. 65 is smarter. So I move on to 53 to 65, and then 65 to 67, then 67 to 37, 37 to 14, 14 to 98, 98 to 122, and then 124. At last it reaches 183. It serves in the request in the order of the nearest. Next is scan algorithm. Scan algorithm is also called as an elevator algorithm because when it reaches the end of the, like a lift, in a lift it reaches the particular positions. Once it reaches a particular positions, it will come back to the ground floor. Similarly, it will scan the entire disk in a single directions. Once it scans in the directions, it will reaches the end of the directions and start reversing the direction and moving to the request. It also minimizes the average seek time. For example, in this, I am starting with a 53, my header. The same example, 98, 183, 37, 122, 14, 124, 65, 67. The header start at 53. It's compared to it's moving to 39. We can move in any directions. It is not necessary to nearest. I'm moving 53 to 37, 37 to 14, 14 to 0. 0 request is not there. Even though request is not there, I am reaching the end. That is the scanning algorithm. Then it moves to the 65, then it reverses the direction, and in the other directions it scans the entire cylinder. 65, 67, 98, 122, 124, and then 183. Next algorithm is the C-scan algorithm. This is also called as the circular queue algorithm. That is, circular queues, it is similar to scan algorithm, but it will scan the entire disk in one direction. It will provide the service, and the another direction it will not provide the service. So The same example Q98, 183, 37, 122, 14, 124, 65, 67. The header starts at 53. In this 53, it starts servicing 65, 67, 98, 122, 124, and then it touches 183 and then 199. Similar to the scan algorithm, it reaches the end of its direction. At last, it will not service the another directions. It will directly move to the bottom and it serves in the next remaining requests. Look algorithm. It is the alternate of the scan algorithm. In this, it will not reaches the end. Similar to the scan algorithm, it will scans the entire directions and also in the another direction also, but it will not reaches the end. It is also minimize the average seek time compared to the scan algorithm. See, I am started here 53, 65, 67, 98, 122, 124, 183. It will not reaches the 199 and it moves back to the 14 instead of moving to the 0. 14 and then 37. It serves all the requests. Now, we will see some previous year gate questions related to this topic. Consider a disk system with 100 cylinders. The request to access the cylinders occur in the following sequence: 4, 34, 10, 7, 19, 73, 2, 15, 6, 20. Assuming that the head is currently at cylinder 50, what is the time taken to satisfy all requests? If it takes 1 milliseconds to move from one cylinder to the adjacent one, and shortest seek time first policy is used. The options are 95 milliseconds, option B 119 milliseconds, option C 233 milliseconds, option D 276 milliseconds. The solution is the given in the order of 4, 34, 10, 7, 19, 73, 2, 15, 6, 20. The question is given as shortest seek time first. In the shortest seek time first is it will traverse in the shortest request will be served first. The cylinder size is given as 100 to 199. 200, 199. So it will start with 2, 4, 6, 7, 10, 15, 19, 20, 34, 50, 73. Currently, my header is present is the 50 in the given in the question. So I'm start here and traversing the 34 is the nearest compared to 73, and then 20 is nearer, and then 19 is nearer, then 15, then 10, then 7, 6, 4, 2. Afterwards, the remaining are 73 is given. So remaining request is 73. Compared to this, we have to calculate the seek time. Seek time is it's traveling in a single distance, that is in a single directions from 50 to 2. So I'm subtracting 50 minus 2 plus 2 to 73. Then plus 73 minus 2. Total we get 48 plus 71, 119 milliseconds. So the answer is 119 milliseconds. Next question is, a disk has 200 tracks, numbered 0 through 199. At a given time, it was servicing the request of reading data from track 122. At the previous request, the service for track 90. Initially, it was present at the 90 and then it will move to the place to 120. So the header initially 90 and then header moved to 120. We have to remember that. The pending requests in order of their arrivals are for track numbers. The tracks are given for a cylinder number 30, 70, 11, 15, 130, 110, 80, 20, 25. How many times will the head changes its direction for the disk scheduling policies? Shortest seek time first and the first come first serve. The options are 2 and 3, 3 and 3, 3 and 4, 4 and 4. In this, shortest seek time first. Initially they given the previous header is 90, afterwards it's moved to 120, and then closer to this shortest seek from 115, and closer to this 110, 130, and closer to this 180, 70, 30, 25, 20. It takes direction changes at 120, 110 and then 130. So it will take the option as 3 for seek times. Then first come first serve. It is also the same given data we have to take for 90 is the previous header, and the next header is 120, and the next is move to 30, then 70, because it serves in the order of what they are arrived. So in the same order, 30, 70, 115, 130, 110, 80, 20, 50. In this it will change the direction as 4 times. So I will explain this example. Consider the cylinder size is 0 to 199. Initially the Q is given 30, 70, 115, 130, 110, 80, 20, 25. So it starts as 90, and then previous header is 90. Now the current header is 120. From 120 is shortest distance is 115. From 115 shortest distance is 110. From 110 to shortest distance 130. After the remaining request, we have to check the shortest distance is 180, and then 80 to 70, 70 to 30, 30 to 25, and then 25 to 20. At last, see here it changes direction as 3 times, from 120 to 110, 110 to 130, 130 to 20. So for STFFs, the change of direction is 3 times. For first come first serve, initially the header is present. Initially the header is present at 120. Previously it present at 90. From 120, it's given in the direction of first come first serve. The same order we have to travel. 30, and then 70, and then 115, and then 130, next 110, 80, 20, 25. It will change the direction as 3 times. Next, see the question number 3. Consider a disk pack with 16 surface, 128 tracks per surface, and 250 sectors per track. 512 bytes of data are stored in a bit serial manner in a sector. The capacity of the disk pack and the number of bits required to specify a particular sector in the disk are respectively 128 megabytes and then 19 bits, 256 megabytes and 19 bits, 128 megabytes and 28 bits, and 256 megabytes and 28 bits. Solve the formula. Disk capacity is equal to number of surface into number of tracks per surface into number of sectors per track into size of each sector. It is in the capacity they given in the disk capacity. We know the formulas. All the values are given in the question. See, the surface is given as 16 and the tracks per surface is 128 and sectors per tracks is 256. The data stored is 512 bytes. So 16 into 128 into 256 into 512 bytes, which is also written as 2 to the power of 4, 128 is 2 to the power of 7, 256 is 2 to the power of 8, 5 and 12 is 2 to the power of 9. We combine all this and we can written as 2 to the power of 28, which is represented right in the form of bytes is 256 bytes. For number of bits, they are also same formula similar to this, number of surface into number of tracks per surface into number of sectors. Instead of writing the size of each bytes, we can write capacity is equal to 16 into 128 into 256 sectors. It is written in the form of 2 to the power of 4 into 2 to the power of 7 into 2 to the power of 8, that is 2 to the power of 19. We can read the number of bits is 19 bits. So the answer is 256 megabytes and 19 bits. Next question is, a hard disk system has the following parameters. Number of tracks is given 500, number of sectors per track is 100, and the number of bytes per sector is equal to 500, and time taken by the head to move from one track to the adjacent track is 1 milliseconds, that is rotation speed is equal to 600 rpm. Disk transfer time is equal to 0.5 milliseconds. What is the average time taken for transferring 256 bytes from the disk? That is, options given as 300.5 milliseconds, 255.5 milliseconds, 255 milliseconds, and then 300 milliseconds. The average time taken for transferring is equal to average seek time plus average rotation delay plus average disk transfer time. That is, average seek time is, it will take us given as 500, number of tracks is 500. In this tracks, we have a cylinders as 0 to 499. That is, its space is between 0 to 499. So we have to divide an average means 499 by 2. So I am calculating as 499 by 2, that is 249.5. This transfer time is 0.5 milliseconds given in the question. Given rotation speed is equal to 600 rpm. Per minute it will take 600 revolutions. For 60 seconds is equal to 60 seconds equal to 600 revolutions. 1 revolution is equal to 60 divided by 600, that is 1 divided by 10 seconds. For average rotation delay, we have to take an average 1 divided by 10 whole divided by 2, that is 1 by 20 seconds. It's given in the form of seconds, we have to convert into milliseconds. So it's 1000 divided by 20 is equal to 50 milliseconds. The average time taken for transferring is equal to average seek time plus average rotation delay plus disk transfer time, that is 249.5 plus 50 plus 0.5. We get a 300 milliseconds. For this we get the answer as 300 milliseconds. Next we move to the conclusion. Conclusions in order to improve the efficiency of the performance of operating systems, because if for example if some cylinder number is 1, of some cylinder number is 500. If I want to travel from number 1 to number 500, at the time it will take a long access time. In order to avoid this access time or reduce the access time improve performance, we have to use this first come first serve algorithm, shortest seek time first algorithm, scan algorithm, scan algorithm and the look algorithm. By using this algorithm, we can reduce the seek time, and also it minimize the seek time by using this algorithm. Thank you. We'll meet in the next section.